Hello, welcome to my presentation towards the role of OPCUA for Gigafactory battery cell production. My name is Schmetz. I'm a part of the Fraunhofer Research Institution for Battery Cell Production in Germany, in Münster, and also especially part of the Digitalisation department, Digitalisation for the whole battery cell production. So in this talk, we will go into the depths of what we are doing and especially what are the requirements we see in there and the potentials we see in using OPCUA, but also the blockers and what are the next steps into the battery cell production for the usage and the role of OPCUA. So first of all, let's go some information about what we are doing in here. So we are part of the Fraunhofer Society, and especially what we're doing in here is we are researching on the battery cell production level in there, and especially, this is very unusual on that, especially on the scaling capabilities. So we're calling ourselves a gigafactory because we are doing production capacity of rather 7 gigawatt hours per year, so this is very large scale for the production in there. And with this large scale production, we are also doing research on the scaling of technologies in there. So especially for the scaling, you see we have different partners, and using all of the partner network in there, we can then shift around the new technologies from the lower technology readiness levels to the higher technology readiness levels, and especially the higher levels. This is where we are doing our scaling work and scaling research. So especially we are doing this in different steps. So we see we have, of course, something like several hundred square meters of floor space already with machines running. We're doing right now the ramp up phase of a first factory, and then in the end we will have the Gigafactory in the upcoming years. And so you see, based on that, especially the topic of scalability is crucial to us, and especially also when we're doing everything in there, we need to kind of an efficiency when we're doing especially our digital infrastructure in there to be supportive for all what we're doing in there. So just 1-2 sentences or slides for the actual battery cell production, because not everyone is aware of the actual process chain in there. So you see we have 3 main stages of the battery cell production here. We start with electrode production. We have to see more like typical process steps like dosing, mixing. We have the coating and drying steps, also the calendaring and doing splitting and vacuum drying of the electrodes. So we see for the anode and cathode as well. And we go to the cell assembly, where we then, depending on the actual cell we are producing, so based on the prismatic, pouch, or round cells or cylindrical cells, slightly differs in there for the whole assembly steps. Especially the machines are differing very much on that. And in the end, we have a self-finishing phase where we're having also the formation folding, especially for the power cells, but also the aging quality control before we have our final cell. So all in all, it's a very complex process chain and much steps to be looked into. And especially this also means our digital infrastructure has to be coping this as well. One dev on that, for example, with electrode production, you see different kind of process steps in there, and also they have different quality parameters. They have multiple or different kind of products and also different kinds of defects. So very much things we have ongoing in there, but also need to having our digital infrastructure to be capable of all that to be aggregated in there, but also getting the information and the data from the shop floor. So talking about digitalization already. So what are we doing in here, and what our vision on that is? So we're of course doing also digital twins in there, and we have different domains. I want to bring them together because in battery cell production, we have, for example, the domains of our environment is crucial. So for example, I think of having dry and clean rooms is very crucial in there, but also other things that come up in there, and we're very energy intense what we're doing in there. So based on that, taking just our prefab as here as our mock-up of what we're doing, target of the digital twins. You see we're having some digital twins for more building or environmental stuff. So with this, for example, doing with the clean and dry rooms, our lab factory, or also the our warehousing has to be represented by that. We have also of course, for all of the machines, exemplary here with the coder. For all of our machines, we then have a digital twin per machine. And of course, all those have to be communicating with each other. And of course, also our products. So starting with, for example, intermediate products or raw materials they come in, maybe for a foil, for example. After we have to produce a slurry and having a coating in there, maybe we have an intermediate product. And in the end, of course, we have a final cell. So all of those digital twins all together need to communicate with each other and targeting different domains, which leads to many things we have to process in here, but also the question for information and how to bring in the information between different systems is very of interest for us and one of the key aspects we need to do in the digitalization. So if we now go to our landscape, so it's a very rough sketch, and on here you see, for example, we have on the left side, you see we have these our shop floor level with the different machines. We may recognize the icons from the electro production, for example, in here. We have an edge level on top of that, so typical edge devices doing the actual data acquisition, providing information and more. Then we have the IoT level, so we have an IoT platform, which is capable of having data pipelining and everything to be connecting different systems. And of course, in the top level, you see different kind of systems. Of course, one of the major systems is the MES, which most production sites now have, of course. But of course, there are also other systems in there. So we have an expert system, especially for the training stuff and giving experts in based on the expert knowledge from the domain experts. We have the digital twins we talked already about. Of course, we have some analytics and machine learning in there, but also many more added systems and services based for adding value to what is going on in there. And so with all those different systems and levels in there, we have some very specific requirements we can relate to that. So this, for example, we need to talk about the semantics and nomenclature when we're talking about what data is being transferred and or what information is being transferred, but also it's about how are the interfaces looking like, because to interchange information data, we need some kind of interfaces, right? And based on an overall step we also have to do on that is the actual data quality assessment. Because you see, having low quality data, you will have also low quality analytics in the end. So this is what we're doing in here. And now the question for us has been where to be using OPCUA as a best model. And so maybe go to the perception, what we saw based on the different experience we have from the pre-studies we did. We also had many discussions with all the equipment manufacturers and vendors, several dozens of them, but also for software vendors, for all the different services and systems in there. And what we saw already, and usually was more or less the same, was something about the perception of OPCUA when talking about that. So first of all, you see the image on the left side. You should recognize it because it's a typical OPCUA Foundation image. But I see the lower labels in here coming from the specific protocol mappings, client server, pub sub, and the basic model access. This is something most of the vendors and suppliers are promoting in that and showing to the outside. So saying, okay, so we are kind of an interface. And giving by that, they are also focusing on the actual interface stuff. And this is, on the one hand, of course, talking about interfaces is nice, but on the other hand, this also comes at a price, because by the perception of that, this results in people starting to compare OPCUA versus an MQTT versus REST or versus Kafka something. So this also then means you get in a mindset where you have a comparative between OPCUA and the other protocols, which are only for the actual interfacing and data transformation, data pipeline in there. And by that, of course, you leave out many of the actual features and potentials of the OPCUA, but also by that you apply KPIs that are bound to interface only systems and protocols now for OPCUA. And based on that, of course, OPCUA has not the easiest stand in there, making things more complicated. On the other way around, you see the top levels are completely left out in the perception of most of those vendors and suppliers. But if we go now up to the higher levels, this is especially something we see by the integrators and also for several services suppliers. They want to have exactly those. So these higher levels now are bridging the information and the domain knowledge, and especially. So there's a high potential in there. And of course, so now by that, they're also the enabler for a faster revamp of solutions and the production. So by that you see in the perception, there's a misalignment between what is promoted mostly and what is the actual benefit and where it should be promoted and perceived. So this is one of the key results we have in here, and also something we also want everyone in this round to be thinking about, and maybe also help other people to shape the perception of OPCUA there correctly. Also, now looking back to the system itself, there are different kind of potential at different steps. So let's start with the lowest level. Of course, we are going to the equipment again. So of course, as we said, for the equipment, there's of course this topic of interfacing. So instead of multiple completely proprietary interfaces from different vendors themselves, now we have an interface we can rely on in the first place. So this is one of the key benefits in the first place. But of course, then for your channels alerting, for fast indication, and also a classification of my information and data coming through, very nice to see in there. But of course, these are the basic features. We now want more. And one special focus I want to hint all of you into is something like the context-aware pre-processing. So we have been talking about already that the actual data quality is crucial for the actual analytics we're doing afterwards, right? So if you now look into data quality and data quality assessment, I think most of you, when seeing all of those topics in here, you feel familiar because all of those are something that are hurting you. Everything placed in here is something that can occur when applying or when aggregating and acquiring data. And of course, this is something that's directly impacting data quality. So we need to address this data quality. In practice, mostly it's something like per machine. We have a pre-processing, and then afterwards also our analytics team still has another pre-processing round in there. And there are some studies out there which are also targeting or coming to an end that most of the time data scientists are using are actual for the data quality assessment and the pre-processing, not for the actual analytics. So other way around, for the people that are having a production and want to get a benefit of the data analytics, most of the time the analytics team is not doing work that's definitely beneficial. It's more like they're preparing to do the actual work. And so by that, everything we can do for aligning, for making it easier, or having a standardization type of work for the actual data quality assessment, this is directly benefiting everything of our capacities and our personal performance and efficiency in there. So you see, this is very crucial to have in there. And now we're talking about the OPCUA potentials in there. Of course, we now have all those problems and all those data quality assessment tasks we need to do. But on the other hand, we also have our specifics, our information models in there. So we have knowledge about what kind of data sources we are talking about, and also we know how those are linked together. So based on that, of course, if I have something like a temperature sensor, I can usually more or less apply similar algorithms for the pre-processing, just one example. So if I now by the first step of the onboarding, okay, this is this kind of a sensor, I can by that directly hint and help for the actual pre-processing tasks that I need to do with the actual raw data in there. So by that, we see a high potential of taking all of our knowledge we have, formalized as companion specifications, core information models, and vendor-specific extensions, so the typical models in there, and taking them with the existing algorithms, and by that relate how is a data pipeline for pre-processing be looking like. So by that, we can directly reduce the amount of pre-processing time and effort for the actual analytics team. So one of a key focus case I want to bring in today, because we also see that at our factory, but also for our partners all of the time, this is something of a crucial part. They have lots of work to do in there with data pre-processing. So there's a very specific focus case in there, of course, but more potentials there. So let's go back to the actual systems view. So coming now more and more from the shop floor level to the higher levels, of course, we go to the IoT systems. And of course, again, it's about the interfacing again, but there's also the topic of the device onboarding, because in the end, you have a data acquisition, but your IoT platform or other platforms you're using in your production, of course, there are some, or there's a requirement for having an onboarding. So you bring in your whole system into the digitalization or the digital infrastructure. And of course, you have to reconfigure everything in there. So what we saw for most of the vendors, or especially for IoT platforms, for other systems and more, and also looking into the IoT, for example, open source IoT systems, usually there's someone having to onboard, someone having the job for onboarding devices, having, for example, a lot of dialogues or something to click through and to bring in all information which is technically already available inside the OPCUA companion specifications, for example, the basic information models or others. So this is something, we have information already there, but we have a redundancy in bringing them into these systems. And I know there will be today a nice presentation, a nice keynote by Eric Brandstedt. He's also doing exactly into this domain with the topic of the semi-automated device onboarding. So just a hint for this keynote, very nice to see in there. And it's something that can also reduce the effort and the time needed for actual onboarding drastically, especially when you're talking about higher scaling factories. So for us, for example, we will have something like hundreds of devices in the end. Having a slight optimization of the actual onboarding time is very, very nice for us because directly has a scaling functionality in there, and by that, high impact on our efficiency and the actual time needed. So this for the IoT level. We're going to know more upwards. Of course, something has been very popular in the last years is something like, okay, we now understand very fast how our base KPIs and production state is looking like and what's going on into my production. So I can directly connect with the compatible systems and see, okay, so which of my machines are working right now, what's my job status and more. And based on that, for example, you saw especially demonstrators for Marti/OPCUA for machine tools, where it's very fast and very easy to exchange different kinds of, for example, KPI dashboards based on my for my whole production. So very nice to see them there. And of course, this is one potential that has been very in focus in last years, but more capabilities also available. So for example, if I'm having a more dynamic production in there, or if I'm planning, for example, having multiple systems or multiple machines with the same processes, but with different capabilities, I can now bring in my capabilities into my information model, and my production planning, for example, my MES, can then take into account all of those information, the capability in there, to get a better production planning and detailed planning steps. So one more idea would also be then, if we're going to the high level analytics and services stuff. Of course, there's also now, if we have some solutions developed in there, if I have a new factory somewhere else, especially for the battery cell production, you will see there are more and more factories upcoming. It's something like once a month there's new Gigafactory being announced from different industry vendors. So of course, if now there's a solution developed, we need to have a transfer of the solution. If we now have to just adapt each of those data points per factory, per vendor, this is a high level of work we have to do, and of course it's not very error prone. If instead we have a full-fledged component specification in there for OPCUA, and we can directly connect with the same data points by out of the box, to say it like that, it would be perfect, because then we have a very nice having a transfer digital solution between our factories. So very nice to see them there. And also many of those services we see dealing with the actual analytics of what is the cause effect relationships in the service in my production, what's going on. So if I now have all this knowledge already available and based and linked to my component specifications, I can directly relink them again. So by that, I can also have more and faster development times for new services, for example. So just some potentials we see in here, and which we are also working on in the actual battery cell production. So see, there's with OPCUA there are many potentials in there, and also we have to tackle them correctly, because there are some blockers already in there. And the two major blockers we see in there, on the one hand, is there's no actual component specification for battery cell production, and in general, component specifications require the domain experts. And usually, domain experts, especially for example battery cell production, they are very, very rare. So we have to be very efficient with our experts in there. And also something from the practice we saw in the steps with the pre-studies and also the discussions, we often see a performance and maintenance issue. So for example, many of those machines we get with an OPCUA interface, with everything, they are not capable of having high frequency data rates often in there. It's not a problem of the OPCUA tech stack itself. It's more like how it's implemented and what are the benefit or the perceived benefit in there from the vendors and what they are aiming for. So this is maybe a type of a mismatch at some points of time. So this is also something we have to tackle together. And based on that, now let's get one step further, because I do not want to leave you here only with some problems in there, but also what could be some steps into the solution. So first of all, let's recap. We saw there are some problems, especially for battery cell production. So there's no component specification available right now. There's no final list of relevant parameters. This is especially because battery cell production is a very complex process chain, but on the other side, also something not very finalized yet. So some weeks there's a new paper or a new insight on a new cause-effect relationship. So based on that, your relevant parameters may change. So this is very agile, fragile at the moment. And the last part I also mentioned is we have limited amounts of experts right now. So there are singular approaches, of course. So we are not starting at a green field. Yeah, there are similar approaches. So for example, there are some OPCUA component specifications that may be reused. So talking about, for example, plastics and rubber, they are very similar in some parts of what we are doing in the mixing phase of the actual battery cell production steps. So there can be something of that can be reused, which is very nice. But of course, not everything. So there are still missing points. And for relevant parameters, there are many research clusters, organizations, industry, more lists are created. So there is something ongoing, but there's no final list or aggregated list or something like that. And of course, for the experts themselves, especially coming from the computer science domain, they're creating more and more ontologies for easier knowledge exchange and to link knowledge together. And so you see there are singular approaches. And now, of course, the best idea would be how to aggregate those kind of singular approaches. And so on this step, I also want to feature an initiative. It's called Enlarge. What they are doing is they are aggregating all the relevant parameters for all those different research clusters, organizations, industry, and own experiments. They are building up in the next years a kind of a meter standard for OPCUA as a component specification, meaning it's not a complete component specification only for battery cell production, but it's more like how to link the existing OPCUA component specifications together best to achieve like a meter OPCUA component specification for battery cell production. Of course, in the end, there will be some white spots that are not addressed already by the existing component specifications, but for these white spots, then there will be specific addressed commercialization work for these white spots especially. And of course, in the end, there's of course the typical validation demonstration, but especially with the industry. And so this initiative is part of several research institutes, but also a large set of industry vendors in there being part of, and the VDMA also for the standardization work itself. So you see, this is the next step we see in the future, and I'm very happy that we're also part of this initiative. And we hope that you see having all those potentials we saw in beforehand, now can using this result from Enlarge to in the end having all of this to be placed inside the industry for battery cell production domain. Yeah. So what we saw today was so there's battery cell production. Of course, it's a growing market. More and more gigafactories are announced. We have a high process or high complexity process chain. We have different domains we want to integrate, and we saw OPCUA has a high potential to be integrated in there and to leverage all of these potentials. But currently, there are some problems with OPCUA, especially in the perception and the foci. We are working on with it right now. And of course, into the future, there's something like Enlarge. One of many things that are ongoing can take a major step on leveraging all those potentials. This has been my talk. Thank you very much. And of course, in case of any questions, please feel free to get into touch. Thank you very much.